All right, welcome to the December 2nd Arborist call. We're excited to have Daniel from QEDIT with us today. For those that may not know, Arborist calls, we have them bi-weekly now. It's where protocol contributors get together to talk about upgrade timelines, protocol R&D efforts, design, implementation, potential features, new features, anything and everything protocol. The purpose is to make it more accessible so that a wider set of participants can join and participate, but also make it, transparent for the community. Like, here's what's going on at the protocol level. So we come together every couple of weeks and summarize kind of progress we're making and things that we're thinking about doing in the future to get feedback on it. Anyone can participate, like anyone's welcome to join. If there's a topic that you'd like to see presented or you'd like to present, you can just let me know, Steven@electriccoin.co. Or you can reach me in the Zcash R&D Discord and just request, a presentation slot or for someone to address a particular protocol issue or discuss it, in a future call. So we normally would have like, standard node updates and things of that nature where we get, what's going on with ZebraD and the great progress they're making, and ditto on Zcashd. We kind of get that out of the way, then we drop into an open format discussion. We're going to do it a little different today because Daniel from QEDIT has, a hard stop. So we're going to kind of kick it off there. So Daniel, I'm going to stop sharing. I don't know if you have slides, but that you want to share. But at any rate, I'll get the slides out of the way so we can all see each other a little better and just have a discussion.
So I actually didn't prepare slides. I felt like I had the feeling that it's a bit more informal and so on. I
no
guess
problem. Yeah.
I'm wondering maybe to get everybody on the same page, like how many, like who didn't kind of go through the proposal on the forum, and should I sort of maybe just share that my screen and have a bit of an overview on that?
That would be good. Yeah,
that'd be good.
That would be helpful, I think.
Yeah, sounds good. Sounds good. So let me just do that. Okay. Does everybody get to see the screen right now?
Looks good. Yeah, looks good.
Okay. So let's see. Feel free to stop me at any point.
We will.
Okay, just one size higher for
Sure.
the text, please.
That works.
My eyesight isn't what it used to be. That's perfect. Thanks.
No problem. So yeah, I'll go like section by section, but I'll skip kind of overview very fast. The first ones, I guess just to put everything into context, why now? Why QEDIT doing this? Well, we've been focused on enterprise all of our life, and we definitely have certain skills that we feel maybe are a little bit more underused because the enterprise world hasn't kicked off as much as the open world, like the open source world of blockchain. So we've definitely kind of pushed to feel like we have a bit more of an impact in this place, and given our close relationship to the Zcash ecosystem and the ECC and Zcash Foundation, in our previous audits, both of Sapling and Orchard, we felt like this is like the right move going forward. So we're great believers of privacy. We always tended to use in our products cryptography and zero knowledge proofs for that, so that's great. In terms of the ZSAs, just to say that we actually had a product that we built that was essentially ZSAs on Sapling, but for enterprise products. So we didn't actually kind of deploy it on a blockchain. We had kind of more of a test environment and so on, specifically on Ethereum as a kind of L2. And in that sense, we have a very much like product perspective on how to build ZSAs, right? Like how to build this ability to create more assets. And we come from more of a federated setting, but I think there are some learnings that we can bring into this permissionless setting, especially when it comes to issuance, because it's not clear that issuance is going to be fully permissionless, at least not for every type of asset or something. But again, this is all up for discussion, right? So just to say that we want to make sure that our proposal and our work focuses around usability, economic concepts and aspects, especially when it comes to issuance and fees structures. And of course, technical feasibility and security. Yeah, as I said, we did the 2 orchards of Sapling and Orchard. We've also, been leading the ZK proof standardization effort. We've led the ZK interface interoperability standard and are currently working also on a research program with DARPA, specifically called CIV. And so that's all for the context and introduction. And we can get a bit more into the technical aspect. So really what we believe is that building ZSAs has sort of these 3 major features or components. And that's how we decided to structure the proposal. And it starts with really enabling multi-asset type at the transfer level, right? Because this is sort of where the core component lives in terms of having an identifier that represents an asset type, being able to prove that what you're spending and outputting is of the same type, that the balance is now going to be preserved depending on the asset type and not generically, things like this, right? Because of course, every asset will now have a different value. Even though it's not going to be represented on chain, you still need to enforce certain things around that. The second one is around issuance. Now that we have multiple assets, we cannot rely purely on minting through mining, like Zec does. And so we need to establish a way for users to generate native assets, but also potentially for users to import assets, say from the Ethereum ecosystem as ERC20s or whatever standard your favorite standard is. To be able to represent it in a shielded asset format, right? And the third feature is about understanding what's sort of the optimal fees structure for these new type of multi-feature, or if we wish like to say multifunctional blockchain, right? Because we're not going for smart contracts because programmability is difficult in zero knowledge, but we're enabling little by little some form of extra functionality and utility, right, on the blockchain. And that means that verification and validation of transactions will have different weight depending on the kind of transaction. So we want to, not reinvent the wheel, but take sort of the best learnings from other ecosystems and make sure that we at least get it close to right in the beginning. So when it comes to again, I think the most important thing to say is that like we're still really like early in this. Like we haven't done any very like deep technical design work. We've been looking at design that have been done, especially by Dara, Strad, the ECC team. I think Ian Myers also has been doing some ideation around how to do ZSAs at a technical level. So we've taken some of these ideas. We've tried to combine also the learnings that we had from building the QEDIT asset transfer product, and we're proposing to start really going in the direction of substituting the base point of the value commitment by sort of a random base point. I don't know if you want me to get really technical low level, or maybe we should do a little bit more high level overview, and then if you have specific questions, get into that one.
Yeah, I don't think we need to go too deep in.
I mean, Strad and I already understand it.
Yeah.
But so don't ask us, ask everyone else whether they need this.
Sure. So yeah, just to say like the high level of the technical part is that at the end of the day, what the most important aspect of the ensuring there is that the value is preserved, right? The balance is preserved between the different nodes that you're using. And for that, the best way, right, Orchard amazingly does it in a single commitment to combine the 2 values. And in order for us to be able to balance that, we want to make sure that you are going to be able to balance the nodes, the values of the nodes that have the same type. And the base point will represent that type. even though it will not be necessarily the actual string that defines the type. That's just a technicality that Dara and Strat actually figured out pretty nicely. So that's pretty cool. And essentially, you will have to add that specific ID that will be unique to the node itself for the node commitment. So the circuit will have some changes, but there are some tricks in order to make it so that it's not going to grow too much or have to change too much.
Yeah, well, if I can just interject,
Yes.
when we were designing Orchard, we made sure that there would be enough room in the circuit below 2 to the 11 rows to accommodate precisely this mechanism.
Yeah, and similarly, the intention was that if it were desired to be able to add this into the existing Orchard pool, then it could be done so in that the note commitments for the ZEC. It should be possible to design the note commitments for the assets such that if you derive them for ZEC, you get the same as already in there.
The way I'd imagine is just that ZEC would be slot 0 in every transaction.
Yeah. You just need the commitments to still work out, but the commitments are paired as ineffectively, so you can make it work.
Yeah.
I have questions, so I will hold them. Okay. So for all of these types, would they require a node update? Would they be part of? How customizable are those on the fly versus should we be doing some sort of network upgrade to support a new type? And this is both to Daniel and to the rest of the Zcash kind of cryptographers.
So thank you for that question, Deirdre. That's great. I think in my opinion, and maybe I hope I'm getting the question right. We're not trying to like sort of fix new asset types at the protocol level, like hard coded it like ZEC. We're really trying to give like the flexibility to issue any new type that any user would like to issue.
Yeah. The restriction in the circuit is about how many types you can interact with in a single transaction.
Exactly. So we will have to find a way to fix that among all of us and the community to make sure that we give enough space, but still being able to maybe fit it in the current circuit size limit, or at least sort of figure out a way to make it work there. But
yeah,
that's
a combination.
You can probably easily fit 10 slots without going above 2 to the 11 rows.
And to be honest,
so
from my experience,
you probably don't need that.
Yeah, and from my experience in working with other cryptocurrencies and like ecosystems, it seems like that's already enough. Like I don't see a situation where I'm going to send 10 different types of assets in one single transaction.
Mm-hmm.
Yeah, the only thing I could consider there would be if someone's trying to do something like an NFT, something where you're treating an individual asset type as a unique asset, then you would be in a situation where you would need to use multiple, like each of your non-fungible assets would need to be a separate asset type within the transaction. Mm-hmm. If you consider that you're dealing purely with fungible assets, then I think I agree that like a bound of 10 or something is probably more than sufficient for anything.
But even with non-fungible, would you need to be able to send 10 NFT? Sorry, well, you're presumably paying for it in some other asset. So then you have ZEC. So would you need to be able to handle 8 NFTs at a time? That seems more than sufficient to me.
Exactly. It comes down to like what is the motivation for that, and what is the motivation for being able to atomically deal in that many separate asset types at once. Because you can obviously just chain several transactions to the same effect, but it's no longer atomic. So yeah. In any case, there's going to be a bound there's a bound on the number of inputs and outputs you can have in a transaction anyway, due to the transaction size limit. and implicitly also in the value balance part of the spec to prevent hitting overflow. There is something like 2,100-ish or something is what we set it to. It was derived from the transaction size limit.
Right.
But anyway, so like we can't. There's no point in having more slots than we can fit outputs in a transaction. But I think that limit's going to be way higher than what we actually fit in the circuit.
By the way, I brought up this HackMD. I just sent it on the chat in case anybody wants. I'm just taking some notes, and it would be helpful if others also help take notes. But I had also a thought about this, which is sort of would having different amounts of assets in different transactions actually kind of give some give up some of the privacy in the transaction type. I mean,
I think we would want to have a fixed number of slots.
What?
For indistinguishability.
Mm-hmm. So actually add some kind of like dummy nodes type for the other assets that are not used, right? For the other asset types.
Yeah, the slots can be unused in a given transaction.
Yeah. Because the way that you bring in a slot is just a commitment to the list of identities that are within it. And so you're not revealing what ones go in. You would just have the other ones be unused. Yeah.
Any more questions on this part without getting?
Mostly an implementation detail. We would probably, the types would probably be a very like narrow, verifiable type lists, like integers. Like you can only pick one of like a number of integers or something like that. And then double checking our implementations of group hash into the Palace group to make sure that attacker defined data as an input doesn't do anything bad or leak or things like that would be much more important than we shouldn't have any of those issues anyway when we always know what our possible domain separators into these things, but they were all hard coded. Like we know all the things that we're putting into group hash P for Orchard right now, and now this will be expanding it to like a bunch of possible stuff. So I guess we could like literally enumerate all the possible values of the types, and then we can double check on how they behave. And that's probably easy, especially if there's only like 10, especially when there's like low numbers of them. But that's just one of the things.
I think we would want to support a number of types that is not easily
computable.
I guess if you supported 2 to the 32 types, you could just exhaustively check all of them.
Right.
But wouldn't that maybe be solved by having sort of this idea of a registration transaction where like you're actually registering and this is transparent. So before you mint it into circulation, you maybe want to say like, hey, I'm going to issue this asset and it has this type. Here's the string. You can then everybody can then verify that this is kind of it stands along, not to have any breaking points or something.
Right. Even so, we can identify them however we want. It can do whatever they want. But whatever the value that we're putting into that that domain separator into the hash function, that was the only thing that I was like, let's make sure that we tightly constrain these attacker controlled inputs into this hash function, and then everything else is like, sure, we'll figure that out.
So checking for collisions doesn't actually help you because if an adversary knows the discrete log relation between any 2 bases, then they can break the system. So
right. I'm not even thinking discrete log. I'm thinking like leaks because of malformed attacker controlled data or something like that.
I see.
Whereas if we're validating the set of those possible values for those IDs, even those IDs might go to something else. I don't want to rabbit hole, but
yeah. This also ties into.
You do need a stronger assumption on the group hash than we're making for Orchard.
Oh,
But
I see.
it's only a little bit stronger.
Okay.
And also note that you can know upfront what all those group hash outputs are going to be. So they can all be deterministic and well generated and not adversarially controlled inputs to generate those bases. Whereas on the asset ID generation side, you're correct there. And we also need to think about, for example, if we wanted to enable issuance of classes of assets like an ERC20 or something, you would need a way to be able to like map their external IDs to an asset internal ID and so on.
Oh, yeah, I forgot actually, you don't need the stronger property on group hash. That's fine.
I'm excited to get really like down to the work on this stuff. Okay, cool. So for issuance, I guess, as I said, like the main point here is that we do want to allow for like native issuance. So at some point in the earlier discussions, I felt like the community was thinking a lot about importing assets, and then it would be easy to say sort of, oh, you know, let's hard code ZBTC and ZF and allow for those two types to run around, given there is some reserve and, you know, there is a multi-sig signing issuance mechanism or something, which definitely is a possibility for importing assets. But what about native assets on ZEP, right? I think it's, in my opinion, an important aspect of the evolution of Zcash, in QEDIT's opinion as well. And so there is sort of two components to issuance that I think I want to discuss. One is this idea of having these two types of transactions. One is registration and the other one is minting. And sort of registration is maybe simpler in the sense that there is a single, let's call it a registrar, that is going to send that transaction with a transparent address and a transparent transaction with a Orchard address, but the transaction itself is transparent. It's also a question whether we want Sapling or transparent addresses to be able to do registrars. But for now, I'm going to limit the scope to only Orchard because I think it's going to be simpler to think about. But then when it comes to minting, well, there can be several ways of minting, right? It could be that, you know, the registrar is the only authorized entity to mint and send that asset to a different address. Or it could be that like users can somehow redeem those assets or mint them, right? Like today, I actually, you know, went and bought an NFT, okay? And you go and mint it yourself, right? Like you actually do this thing by yourself while exchanging for some value. And the question is if we would like to do that as well. I think it has a benefit. But you know, there is plenty of ways to think about what minting could look like. We're not going to get super generic, but at least incorporate a couple of fundamental ideas there would be interesting.
With my hat on as a full node maintainer, the main thing I'm looking at here is how much state do the full nodes need to be maintaining? So currently our state we have to maintain for tracking things is we have the regular UTXO set, we have the set of commitments, i.e. the commitment tree for Sprout. We actually have to maintain all of the commitment trees for spinning purposes. For Sapling and Orchard, we just need to maintain the roots of the trees and the latest form of the tree. Zcash also maintains all the previous tree states, but that's we can optimize that later. We have to maintain the nullifier sets for all of the pools. And I think that's basically everything. We obviously have a block index and things for quick access amongst whatever, and then you have the chain structure and whatever. But that's all the sort of like the actively mutated state we currently have. If we bring in TZEs, which we've discussed previously, that would add another transparent UTXO set, which behaves effectively similarly to how transparent UTXOs behave, in that you would have a list of currently unspent UTXO, unspent TZD outputs and their preconditions that must be satisfied in order to be spent. Those preconditions, the way we've currently sketched them out, would actually end up being probably larger than UTXO preconditions, which is generally just a script hash. But that's partly intentional because we want to, well, partly maybe and partly no. It depends on how much logic goes into the preconditions versus how much is baked into the consensus rules, but whatever. Yeah. So that's the full set of things I can think of at the moment in terms of what a full node would need to deal with. So the question then becomes for this, is the issuance mechanism proposing working within one of those, like storing its state within a TZD output or within a transparent output or whatever, or is it proposing a new set of state that needs to be mutated and managed, in which case, who needs to coordinate on updates to that state?
So I don't have an answer right now, but I think this is exactly the right question, Dara.
Well, you could implement this in terms of TZEs.
Yeah, that is one approach.
In which case, it would be a subset of the TZE state.
I think the question there is really, like, for me at least, is how extensible is that for future updates of whatever? I mean, right now we're talking about it works with TZs because it's going to be a transparent system. I don't know if it's going to work with private system, but then you would have to sort of re-implement everything again.
Well, I mean, do we want to be able to mint tokens privately?
I think that's the first question.
If it's not permissionless, then maybe.
Exactly, but I will say that it's probably not going to be in scope for the proposal.
I agree. Private minting probably won't be in scope here, and probably in the first pass doesn't make sense. But the question of, do we want to think of that as a direction might be one thinking about.
Mm-hmm.
I think that's something that can easily be added later, if we want it.
Two TZEs, like
well,
shielded Zcash.
It would probably be another transaction version.
Exactly. That's what I'm saying. That, like,
so to answer,
what do we lose? There is a trade-off essentially, and this is what we need to really analyze. If the state that needs to be stored by bringing a new transaction type or version is not big enough to, so maybe not big enough, but it's small enough to say, let's do that instead of having a TZE that would potentially limit us in extending the methods of issuance, then maybe it's worth it. But
right,
again,
that's really the brass tacks here is, so as far as your question of how extensible are TZEs, so the TZE mechanism is just a generalization of the UTXO model. So if your registration and minting mechanism can fit into a UTXO style model where you create a commitment to something that then can only be consumed in a by satisfying its pre-commitment, and your entire database model is a series of creation and consumption of these tokens, these capabilities in a sense, then TZDs will be satisfactory for that. The TZD mechanism, a particular set of consensus rules for a particular TZD can be altered in a future network upgrade. So if there was a limitation in terms of the logic that a particular TZD set allowed, you could alter that to add future extend it with more logic in a future upgrade, as long as the later upgrade understood how to parse and deal with the pre-commitments that had already been made. So this comes down to when you design it, how much data and commitments and stuff you put into the pre-commitments themselves versus how much goes into the consensus code for verifying them. But they're essentially just state transitions, and you can change the state transition function later if you wish. But you are forced within this UTXO model. If the extensibility that we want for registration and minting is forces it to be incompatible with that, instead needing like a knowledge at a global level of like globally allocated tokens and things, and that full nodes would be required to track that, that would need its own separate logic, I think. You could extract that information from the TZD UTXO database.
Exactly, that's what I was going to say. You can somehow make it so that there is a registry or like a block, right? Block
you can do what
that specifically for that.
You can do what block explorers currently do, which is like most full nodes that are running don't bother tracking the transaction index because it's too large, but block explorers enable that flag in Zcash to track that or address indices.
And that's the point of having it as a transparent transaction, that it's easily
indexed and and even if you had shielded minting, you would still need like the concept of registration of your asset IDs to be public in some sense. And also, as a separate note, there's nothing stopping a TZE from containing ZK proofs and having shielded logic. That would be what, for example, Bolt, or ZK channels, it's now called, being deployed by TZDs. The amounts are stored on chain publicly, but the pre-commitments and like spending logic could be entirely private if you wished.
That's really cool. Yeah, and I think it does make sense to go this direction in the first place, because it seems also like the least sort of development effort potentially, or maybe I'm wrong there, but it seems like it's the most compatible method today with what exists.
I guess the other thing
works as an MVP. Like our goal is to create this MVP, and if that gives you the value, then we can do it.
So there is already code for doing TZs on a branch, I think.
Yes, and we're looking to.
It's gated, so it's possible to, on that branch at least, to create a test net that already supports TZs. Yeah.
And we're hoping, like, once we're done with the NU5 stuff, to bring that into mainline Zcash so that, people can just like fork Z, we can start getting actual consensus, potential consensus code into a Zcash branch, whatever, that makes it easier to trial the stuff. But the interesting thing that Daniel's point just made me think about, that we might want to think about, is what would it look like if we deployed this first as a TZD and then migrated to a dedicated registry later if we decided we needed extensibility. We would have all the on-chain commitments that have been made. Yeah, I guess, that if you design it with that in mind, that might put a few constraints on the way in which you build the commitments in the TZDs, because obviously you would need a way to migrate from the TZD UTXO set to the global registrar variant, but that might not be too terrible. Or it might just be that the way you do that migration, if we needed that extensibility, is you just add the registrar version, and then people can just manually migrate from one to the other, if there isn't a way to automatically migrate it or subsume them.
I mean, that you can have arbitrary code implementing a TZE, so it can interact with
the code's not the problem, it's the data. It's the commitments and things that go on chain and how you interpret them later.
Okay. What about the second aspect? What about I'm wondering, if we go for the TZs, and essentially you're going for like a set of unspent transaction outputs, and how does that enable the different types of minting that I was mentioning? Meaning, it seems like in this case, whoever is kind of registering or issuing it for the first time is going to be the one sending whichever assets are being issued to the users that are somehow now deserving to get that. So it's going to be external to the blockchain.
Yes. So in my mind, would have been something like, when you register, it creates a TZD UTXO, TZDXO naming
with say 100
on chain, which just says this asset type is defined. It doesn't even necessarily say how much exists, or it could define its rules, whatever. But now that token, that UTXO, is the capability for minting effectively. And if you then wanted to delegate that to someone else, maybe that, the precondition, the verification logic that allows it to spend that token, that the act of spending it allows you to make a transaction that produces new, like maybe potentially more. So you can imagine having like
exactly.
that.
I was just going to say, actually, that's the beautiful thing about UTXO. From one, you can create more. So I can create a first registry and then create 100 UTXOs from that say, now these people are the ones that are able to mint that.
Exactly.
Which is analogous to what I was thinking. If we had the registry, you just have a list of allowed minters or something.
Exactly. Yeah. And then the TZD logic could, for example, allow you to revoke minting rights by allowing both the minter to spend that minting output in a minting style transaction, or the registrar to spend that minting output in order to consume it and prevent on-chain from minting any further.
Okay, that's pretty cool.
Yeah, that basically gives you key revocation for free.
Yeah, modulo,
which I think is really important.
Modulo, you have to get you're essentially competing against the minter to double spend the output. But the registrar will eventually win because the minter has to win every single time to retain their ability to mint, and the registrar only has to win once.
Yeah.
So you're saying, wait, so maybe I missed that, the revocation comes as a specific rule of the TZ?
Well, actually, no, you could probably design it a different way as well. So I was just in that straw man going to revoke, you just have the registrar spend the capability that the UTXO that the minter would have used, and then the minter can't use it because it would be a double spend. Because in the minter's case, the minter spends that token and is given another token for the next one.
Right, but for that, you need the TZ to contain information that also allows a different owner to spend that UTXO.
Exactly, but the TZD logic can do that, because when the registrar token was spent to create the new registrar token and the minting tokens are, that transaction can have bound the minting tokens to that ID and can include the registrar. Yeah. So it might be that the way that you revoke is by creating a transaction that spends both an active registrar token and the minting token that you want to consume, and that becomes like a many-to-one transaction that consumes a minting token and a registrar token and produces a registrar token.
I mean, so one way of doing it is that you can have different public keys controlling different capabilities.
Yeah.
And then you could revoke all of the subtokens at the same time if you wanted.
Yeah, that though starts getting more into, okay, because you could do that where a TZD requires, because TZDs can have like context objects, context of the chain. And this is partly where you can sort of start blending the boundaries between like purely TZD based versus purely a registrar. You could require that the TZD be able to query some metadata about the other TZD output UTXOs of that type. So it might be that full nodes then just maintain a partial, a smaller global database, of just like, indexing into the TZD UTXO set to query like, okay, at this current block height, there exist these particular minting tokens. Then, that might be something that you could leverage. And again, that just comes down to, okay, how expensive it is for full nodes to compute that data during for block verification purposes.
Yeah, so for recovery from key compromise, you might want something like a global exit that converts all value in a given token to some other token. Just a straw man thing that you might want.
Anyway.
Yeah, I think we'll definitely have dedicated sessions for this. And
yeah,
all of
but I think that covers like at least the broad strokes of like the bounds of what seems reasonable to do within at least Zcash's domain.
Yeah, and what Dara just said brought up to mind something that I think other people in the community are keen to see, which is this idea of like asset fungibility, like different types of assets could be fungible because actually they represent the same asset.
Yeah.
Yeah.
Something of the sort, and then
that's hard to do without consensus level support, I would think. You need someone to be the arbiter of like, these two things are really the same thing.
Right.
Okay,
so
you may need the
if you think
register
about,
for that.
if you think about how an exchange works, you don't necessarily need that to be in the consensus rules, because in an exchange transaction, the value of each asset balances independently. It's not as though assets are being magically transformed from one to the other. It's just that you find two people who are willing to exchange the assets at a given rate, but the two assets still balance.
Right.
Okay. Awesome. In terms of importing assets, the idea is that the same mechanism will be used and the reserve and validation will happen externally.
Yeah.
Like we would like to see that seen. We would like to see that happen, and maybe I don't know if the Zcash Foundation, I don't want to name anyone, but someone could take at least an initial step to make it happen, and I'm sure others would follow. Others that have reserves also would follow. We mentioned here multi-sig, but that's, I think, a different. It's probably out of scope right now.
I think it's completely orthogonal to this.
Yeah.
Yeah.
If it's
built to issuance as a multi-sig.
Oh, I see.
It's built.
Yeah.
But again, if it comes down to whether you want introspectability into which keys were involved, as to whether you want a Bitcoin style, you can view all the keys that are involved in it, or whether you just want threshold multi-sig, which is indistinguishable, because the latter we can substitute in at any point.
Yeah.
Yeah.
Okay, cool. And then here, we just mentioned some other extensions, like specifically what I mentioned earlier is this idea of, can you redeem the minting asset on chain, right? By like exchanging it for some ZEC or something. That would be like pretty cool to see. For that, you probably need some more like swap style transaction and things like this, which it's not too far from what it is, but it would take considerable also consensus level changes probably. Especially if we want to do it on privately. And then we go to fees structures, right? I think here, we don't have the economics expertise as applied to blockchain at QEDIT. We definitely want to make it work, and I think this is one of the main reasons maybe why the ECC has contracted the George Mason team. I'm keen to see what's output from there, and here we outline essentially just a default method, which is what exists today, or some low-hanging fruit that depends on transaction size or transaction type or number of assets. I don't know.
Right.
Something that doesn't break privacy anyway. But,
right. Just a quick comment there. It's kind of like the audit report, like that we have a draft one we kind of iterate on to get cleaned up, and then we're going to publish it. We're kind of same thing on the George Mason side. We have a number of mechanisms we submitted for their analysis. We've got their write-up, and we're working on getting that finalized and published. So to the extent that's valuable for this effort, that'd be awesome. But it has different types of mechanisms for fee structures, if you will.
Cool. Amazing.
So Stephen, what's the likely timeline to get that published?
I would say I can't commit to their schedule, with the holidays coming up later in the month, but I would say late December, early November. Yeah. Mm-hmm.
Early January, you mean?
Early January.
Yeah, sorry. Yes. Yes. That's how frazzled I am. I've got months in reverse order right now. Yes. Early January. Right.
Okay, cool.
Yeah, if you hadn't seen it, Daniel, this was the blog post that it gives a little bit of an overview from the report. So that's what's currently available.
Thanks.
Yep.
I think somebody in the forums suggested that the options be presented to the community for their input, and I think that's a good idea, and we'd be happy to facilitate that with the Zcash.
Yeah, and the nice thing is a lot of the, particularly for at least in the transparent cases for minting and things, fees are are relatively orthogonal. If there's a desire for fees mechanisms for the actual transactions themselves, that, and the impact that has on the circuit, that can become a little more complex. And also then you have privacy concerns to think about. Even just the simple thing of, oh, well, just allow people to pay transactions in any, fees in any asset. You then start having to think about, okay, well, now your fully shielded transactions can have fee. We already have the thing of, okay, we try and have all the shielded transactions use the same denomination of fee, so you don't get wallet segregation. But if you start allowing fees to be paid in any asset, then you start going, okay, well, now not everyone's going to be dealing in every asset, and so you start getting weird and cross-asset, pooling.
I'm pretty keen
really
on all of the fees being paid at a fixed rate in ZEC, or at a rate that only depends on public information in the transaction.
Yeah.
Yeah, it should, indistinguishability in a transaction should be a key. Like it should just like another transaction. Yeah.
And having fees paid in ZEC also, reduces the risk of piggybacking. People piggybacking on the Zcash network.
Yeah, like
there is a question on the chat that talks a bit more, or at least triggered my thought in the context of the usability of this, in the sense that, right, the question is, if newcomers that are interested in ZSAs don't have ZEC, how are they going to send fees in ZEC?
Yeah.
But I think the answer is something like, first of all, it's up to us as a community, developer teams, etc., to make it so that an actual wallet for ZSAs will allow you to also sort of hold ZEC easily.
Totally.
In my opinion, if you are going to use ZSAs, there's actually no delta to be able to have ZEC on a wallet.
Right.
Right. Yeah.
Just like
I know
a ZSA wallet has to be a multi-token wallet.
Yeah, I suspect
specifically a ZEC wallet.
Yeah, I suspect though this clearly has a motivation in Ethereum land, where to do any of the Ethereum token stuff, you need to be able to pay fees and gas, and that is quite expensive at the moment in Ethereum land. Like I think I only have a couple of $100 worth of ETH in my MetaMask wallet.
Right.
It's like, cool, I can buy nothing.
Yeah, exactly.
Okay,
the absolute value of the fees as dollar equivalent matters. The fact that
it does.
the default fee is, I can't remember what it is. Is it 5 cents worth or less?
Something like that for ZEC at the moment. Yeah.
It's really
and specifically, I think that the motivation for validation is going to be clearer when Zcash moves to proof of stake, because mining essentially part of the motivation is the fee market, whereas in proof of stake it's more, I think, in my opinion, the staking. But in any case, I do want to bring up a topic that I had in mind before I have to drop off. So first of all, I welcome everybody to check here the rest. I want to touch upon the milestones in a second, but before that, to make sure we touch upon it, is the question of sort of backwards compatibility. Because for every protocol update, there's been this maybe turnstile system, or there is now 2 different types of protocols going on and validated, Sapling and Orchard. At least Sprout is going to be degraded, but we still have a lot of stuff in there. And the question is, for what I call ZSA Orchard protocol, are we going to essentially want to have the same type of mechanism, or should we aim to in some way make a compatibility proof where you can just send ZEC, regular ZEC to ZSA ZEC? Do we have ideas on that?
I'll give my opinion. So in my opinion, the motivation for turnstiles mainly applies when you're making significant changes to the cryptography. So in some cases, as it happens, all of the turnstiles that we've done so far have been ones that were essentially forced by efficiency or engineering constraints. Now, the one between Sprout and Sapling was also necessary to fix the security bug in BCTV 14, or our implementation of BCTV 14. And there's always the possibility that there could be some flaw in the proving system or in a circuit that requires a similar kind of turnstile. But I don't personally, and I know I disagree with Zuko on this, I don't personally see much value in having turnstiles that go between protocols that are almost the same cryptographically. And Orchard plus ZSAs is similar enough cryptographically to plain Orchard that I don't think it justifies a turnstile. Zuko will probably want to disagree with me at this point.
So I hear you, Dara. I think that's.
I'm disagreeing in text.
Yeah.
Oh.
I'm wondering though, in the context of changing the circuit, right? There is going to be a change of circuit, and that's identifiable. And so if I'm holding ZEC in a node, and specifically the node changes, right? A node that is at least one field shorter because it doesn't have the asset type in it. How am I supposed to use that ZEC as fees of the ZSA?
That is what,
okay, so
what we mentioned
one way of
before.
doing that, yeah. One way of doing that is just that if a particular slot in the
new circuit,
the asset type in a given transaction is ZEC, then you just make that part of the note commitment conditional, and that's straightforward to do.
So are
you recommending that ZEC, even in ZSA Orchard, ZEC will still have the same note structure?
Yes.
Got it. Because it's the default, you don't need an asset type, and you're fine
because
to keep it.
Or you could just define its asset type to be like all zeros or whatever you want it to be.
Yeah.
Well, no, but that already changes the whole node. I mean, if you add anything,
you have to make it missing rather than all zeros.
Yeah.
That's straightforward to do.
Not necessarily missing. It depends on how you structure the note commitment specifically, because what matters is deriving the note commitments. And if the note commitments,
yes, but it's a Sincere commitment, so all zeros is not the same thing as.
But a Sincere commitment is under the hood pedersen based, so you can extend, and if you extend it with something where the input. You could design it in a way where, say, if the asset ID is a scalar, then when you use ZEC and use ZEC have the scalar be 0, it cancels out that contribution to the note commitment.
Oh, yes, you could. You're right.
Yeah.
Like, I remember having this discussion with you. I had advocated for having a field potentially in Orchard just for this, and you were like, no, we don't need to do that for this reason.
Yes, I remember that conversation.
Yes. Yeah. So we kept it simpler. So the alternative, of course, is just you have two different note commitment strategies and you switch between them based on that. But
I was thinking that we wanted the asset field to be part of the Sincere commitment input, but it doesn't have to be. It can just be another base in a vector.
Yeah. Like whether or not you do this is sort of more a policy decision at this point, rather than it's technically possible to build it in a backwards compatible way as just an upgrade to the Orchard pool. It can also be done as a separate pool, and if it were done in that way, then the note commitment logic might be slightly simpler.
That's what I said in text too, Strat.
Yeah. Yep.
Okay.
Yeah, to read for the group. Yeah, the decision turnstiles should be made user experience and market integration backwards compatibility. Sorry, I skipped. User experience and market research rather than engineering decisions. And I agree there, like the engineering decision doesn't matter here because it can be done either way.
I almost agree. I think that the complexity of the circuit is a significant factor that we should consider.
I also feel that. Yeah. Okay, awesome. I love
developers
that
use
there
it
is a debate. Let's get that debate fully.
But
going.
we're all agreed that technically it is possible to either have a new pool with the 10 style or keep the same pool.
Yeah,
perfect. Okay, so just in terms of milestones and deliverables, we've basically divided more or less into like design implementation milestones. We have a zip for the transfer functionality, a zip for the issuance mechanism. These two actually have the same timeline, just so that we actually work in parallel in these two and make sure that we do it at the same time, because it's the same feature in the end.
Yeah.
And then we're going to start with the transfer functionality. While we also think about the fee structure, this is also a bit in parallel. And this is something that I feel like was important for us to include, which is sort of working with everybody here on the deployment strategy for whatever is the next NU that will, in which these features will go into, if it's 6 or 7. Definitely want to hear from you what the current expected timeline is for NU6, because I feel like if it was going to be 2022, maybe it's going to be 2023 now, but not clear on that. And also includes aspects of writing in the specification, in the document, the spec. So that we made it a whole separate thing. And of course, then we come with the issuance implementation and the fee implementation. This comes with sort of a review of the previous PRs as well. That's why we call it and full PRs of the 3 other zips implementation. We've included a dedicated node wallet state implementation, so that we make sure that whatever consensus rules, private state in the node needs to be kept. And I think Deirdre, this maybe goes to the question that you were asking earlier. Currently, we outline here that our preference is to do Zebra node, because Rust. Hopefully it will be there. We want to maybe talk a bit about what's the timeline of Zebra at some point with Jack, Deirdre, etc.
Then let's talk. And there's also been some discussions about maybe the Zcash, the ECC folks looking at implementing a new wallet in Rust. So I think there's potentially scope for
makes sense.
Like there will, at least as far as the consensus parts go for Zcash D, there will for quite some time still be some C++ components that are necessary. But as we've been doing with Sapling and Orchard, we've been moving as much of it into Rust as we can. In fact, a lot more of Orchard is implemented in Rust, even in Zcash D, with just like FFI wrappers around it. So we're already heading in that direction, and it might be that you could potentially structure some of the even the consensus pieces in a way that they are usable by both stacks.
That would be awesome. Kind of like we're doing the Orchard Halo crates, for example, right?
Yeah.
Zebra is, I think we are done with all the Orchard specific rules that it's running. We're cleaning up Sprout stuff, that's kind of years old, but we're fully validating Orchard now. We don't have a wallet yet, but we have a full Rust all the way down. We use the Orchard Crate Halo 2. We use a ton of the ECC libraries. We would not be able to do it without their help, but that's ready to go if you want to tinker. Start tinkering.
Yeah, amazing. I know Pablo is here. He's in hearing mode because he's busy with other things, but I think he will be happy to hear that. We were discussing this also this morning. Good. And then we have these 2 other milestones, which are a little bit more vague on purpose, because they're definitely not, it's not clear how to do it now. But for the audit, we didn't want to request funds for us to pay for an auditor. we instead want to make sure that we help and support through the process of finding an auditor that could get a grant from the ZOMG.
That makes sense to me.
And of
Yeah,
course,
we can help with that as well.
Yeah.
amazing.
You stole my joke, Daniel. I was going to ask you what audit firm you're going to use.
I was going to say maybe the ECC, you know.
I mean, we'll be reviewing it anyway, as usual. So, certainly there, like, it makes more sense to generally approach audits from perspective of, okay, what's actually going into a network upgrade rather than, because we do at some level have to consider the interactions. We're fortunate in some cases, like, in this upgrade, there's not that many things that are interacting, but in previous upgrades, we have had cross protocol interactions to consider.
Right.
No, I mean, maybe it's a question whether in that potential audit for NU6 or NU7, it would be an audit of more general of the whole protocol or more components than just ZSA, right? I mean,
Right.
And then of course network upgrade
as well.
Yeah. I mean, in the last couple of upgrades, we've had audits from QEDIT and NCC, so I would be completely happy with NCC reviewing some of this.
Yeah,
definitely.
We've
Unless
used
they also ask
Trilobits
for what?
We've used Trilobits in the past for certain audits. They've done a good job.
Daniel, when was your cutoff?
Yeah.
Was that like 7 minutes ago, or is it in the next hour?
Oh, yeah, it's okay. I have like 3 more minutes, like literally.
Okay.
Leave my house in 3 minutes, so I have the shoes ready to go. Yeah, so just check it out. You have the budget and the timeline. I hope it's a decent timeline. I think we've thought about it with between 3 and 5 people, depending on the milestone, full time. If you have any questions or concerns, please do raise them, because we want to make sure we're not being too conservative, but we're also not on the bad side, right? We all understand that these are estimated times, so if things change a little bit, it's fine. But
I will briefly say that like having like transfer functionality implementation that early in the stack is great, because the earlier that we can get the sort of stack into like starting being integrated into the nodes, the earlier that we can like iterate on them within it.
And again, like there is a lot of overlap between everything, because it doesn't make sense to separate it fully.
Right.
Right. I mean, we want to give at least some,
No,
I think the main thing that we should start early, like we gave ourselves here a lot of time, but it may, practically it's not going to be that much time, but we want to start early to discuss the roadmap, the shared roadmap. What are going to be the features included in NU6 from ECC, from Zcash Foundation, from QEDIT, or NU7? I mean, again, this is a question that's a bit in the air for me, but definitely want to get that going soon. Okay.
Excellent.
Amazing. Thank you all so much for
thank you, Daniel.
listening. And thank you everybody who took the time to chat to us and to me and give comments and review it. And this is super exciting. Very, very exciting, seriously. Looking forward to hearing from
100%. No, this is awesome.
meeting. All right. See you soon, everyone.
Okay, thank you, Daniel.
Thank you, Daniel.
Thank you.
All right, very good. So to kind of hop back to the node updates, Deirdre, you want to provide an update, share your screen, or just chat?
I think we have Conrada doing that today.
Okay, all right.
Yes.
Very good.
Yes. Can you hear me? Okay.
Yes.
Okay. So hi everyone. I'm Conrado. This is my first time doing the presenting in the Arborist call. So basically, what is happening with Zebra? So we're just about to cut the third beta release, and what we worked on this last sprint was downloading sapling sprout parameters. We used it to use a crate for the sapling, but now we just download it in a similar way to what Zcash does. And we also use the same paths for the file. So if the person has already has the Zcash, they won't need to redownload the parameters. We implemented validation, some missing validations, consensus rules like transaction lock times, expiry height, and minor fees. We added support for actually computing these Sprout anchors and save them to the state, which was something that we ended up postponing, and actually validating.
Sorry, I didn't quite hear that.
Sorry.
Something about anchors?
Yeah, we are now computing and saving the Sprout anchors to our state. This is
I
something
see.
that we postponed back then, and we got around actually doing it. We are now validating those the sapling and the orchard anchors, and we're working on the Sprout on validating the Sprout anchors, so that should be done soon. And some random security issues that we were solving, like routing inventory requests by no longer routing them by IP address, but selecting randomly nodes to send the requests. So that was basically what we worked on the last 2 weeks. And what's coming up next is basically finishing those pending consensus rules, so that we finally have a fully validating node. So we're pretty excited about that.
Nice, very good.
Yeah. So but what's basically missing is validating the Sprout anchors and the joy split proofs, which is we already had some progress, and some other security issues, validating, ensuring that hiding encodings are minimal, and that's it. And some random stability issues. So with that, hopefully we'll get a release of Zibo that's fully validated.
Well, what's your level of confidence that the consensus rules are implemented or are going to be implemented exactly as in Zcash?
Yeah, that's a good question.
It's a difficult thing to audit.
Yes, that's a good question. This is something that we want to go over all the consensus rules in the spec and make sure we identify each of them where they are implemented in the source code. We already do that, but we want to make sure go over all of them and make sure we actually point to them. So yeah, right now we have a kind of high assurance, but after we do that process of going over all the consensus rules, I think we should have a good level of assurance of that we implemented everything. But of course, we're still gonna do an audit at some point. But before that, I think after we do this list, check the checklist, I think we have some good level of assurance of that we got everything.
I mean, you have the advantage that you don't really have mining nodes, so any consensus divergence is not going to cause a fork on the network. Are there plans to make mining nodes in future?
I think not yet. We're going to focus on wallet next.
Okay.
I'm not sure. I don't think it's
so. Mining will be after wallet, if at all.
Yeah.
Okay.
Yeah.
Excellent.
So yeah, that's basically it.
Excellent. Nice thank you for that update. We appreciate it. I'd also like to just toss out my kind of renewed suggestion. If we can collaborate, like we'd love to get rid of kind of the Zcash D wallet as is right now with like a Rust wallet at some point one day. And if there are pieces, even if we have like totally different, like, I don't know, call it RPC layers or something on top, if there are components we could collaborate on and share, that would be great,
Yeah.
Sure. We had a bit of an early discussion about this at ZipSync yesterday.
Okay, good.
Just sort of initial thoughts on that, because like with ECC doing wallet stuff for next year, like we're going to have a new backend that we want to build for that, or improved backend, and it's my personal goal that we can also make that be able to communicate directly with Zcash as like an eventual pathway to getting rid of the Zcash wallet. That's last step itself is blocked on the Rust wallet being feature complete, and we have a lot of features in Zcash that we need to be compatible with. So actually swapping out is a while off, but at least making the pathway forward compatible for it is something I'm very interested in.
Cool. All right.
Yes.
All right. Well, I'm gonna thank you very much. I'm gonna get my screen back up briefly, and we'll kind of walk.
But while we're still on the subject of consensus divergence, let's say someone knows about a divergence between Zcash and ZebraD. Should they just report it to you or us, or should they try and provoke it on the testnet?
On the testnet,
Yeah.
perhaps report it, especially if it's on testnet. If it's not on testnet, we have our security reporting communication channels.
I mean, obviously, we can't dictate what people do. This is just a matter of etiquette.
Right. Yeah, if it's on testnet, ping us in public. If it's not on testnet, ping us in private. We have signal channels open between our teams, but also we have a secure address to report security and consensus issues for Zebra, and then we can confirm whether we can collaborate to see on, like, we do this, Zcash does this, who is correct? And like, we have a million and change blocks of what has been correct all the way up through the latest network upgrade. But for the new network upgrade, hopefully it's straightforward enough compared to Sapling that it should be very similar. But yeah, does that help?
I guess.
I think so, yeah.
Yeah.
I mean, it's no different really than how things are today. If someone observes something that they think maybe that needs to be brought to folks' attention, they've got channels to do it. Either, I discovered a bug, so it's, throw it out in public, or it's a little more sensitive, so there's like secure channels to communicate those on. Okay. All right.
So consensus bugs should be treated as bugs in production. It's no longer the case that you're considering ZebraD to be not following consensus yet. You see what I'm saying?
I think all node implementers need to agree on what the consensus rule is, so that we can all collaborate together to maintain the chain state. And so it has to be handled judiciously so that we're not leaking one way or the other, because we're not sure if one of them is a bug or one of them is not following the consensus rule, or vice versa.
Right. Okay.
Right.
Yep.
Excellent answer, by the way. It was very well stated. Okay. All right. Excellent. Okay. So the node update for Zcash at the moment is equal to NU5 work. So that's why we don't kind of have a second section on that. And for sake of completeness, nothing's changed in this list. Just so everyone, if you happen to drop into an Arborist recording and you haven't seen the previous ones, when we talk about NU5, we're talking about this list of new zips. It's a massive upgrade, arguably the largest upgrade that Zcash has done. And then, so those are new zips. We had to update a few zips to account for a little bit of information about Orchard, for example. I hope someone's not crossing the road or something about to get. It's not heard a horn. But yeah, so
loud people outside.
Okay. Just to accommodate for Orchard, for example, like the pool balance not going negative. So a tiny bit of update on some of these zips, but that's the complete list of new and updated zips. In terms of, from our side on the Zcash D side, the remaining work that we have, we've kind of sketched out. We went over some of this in the last Arborist call, but these are, you can call them gating factors or remaining work we need to do, or however you'd like to refer them to them. So one is Mary Mahler's review of the Halo security proof is completed. So reviewed, signed off, thumbs up, kind of sign off.
To clarify, that is it. A gate is that it be complete, that it is completed, not that it is currently completed.
Right. Yes, that's that's why
English is hard.
Thank you.
Yeah,
that wasn't clear.
Yeah. So the items that are completed are crossed out. So they were on the list last time, and we've done them. So I just want to keep that list going, so we can tell the kind of the progress we're making. Sean's made really great, we made progress on all of these. Some are complete, some are not. Sean's made really good progress on this. Sean, I think's on the call. You want to provide any additional info on that, Sean? Or?
Yeah, so it's done. So now Mary is going to spend about, I think she's going to spend 2 weeks looking over it, but we're going to get feedback sooner than 2 weeks.
Yeah,
Mary will continually communicate with us, and we'll probably have a meeting next week where she'll raise questions and then we'll answer them, and then she'll get back to looking at it and things like that. So it's going to be a kind of iterative process.
Yeah, and we've worked with her on earlier iterations of the proof as it's developed. So it's not like it's net new for her or anything, of course. So, and then we've got next up is we just categorized them as Orchard dependencies. Red DSA, Zcash encryption are done, and then incremental Merkle tree we're very close on. Yep. The mainnet circuit, some remaining Poseidon work, multiple opening.
I've done most of the rewrite that we need to do. There's just I need to sit down and finish writing up doing the padding piece to be properly spongy on that refactor, but otherwise that's almost ready for review.
Okay. Multi-point opening is done. The remaining work, ECC config refactor, assigned cell refactor, we're making.
Those are both just in review.
Yeah, those are done in review.
Yeah. So these, by the way, are making the code a bit more concise and less complicated, because the way we were accounting for assigned cells required a lot of sort of boilerplate, and this is reducing that significantly.
Yeah.
And then, by the way, the multi-point opening thing, it wasn't an actual change to the circuit. It ended up not being a change to the circuit or to the protocol. It ended up just being a prop test that we added for some internal stuff in Halo. So there wasn't actually a change there.
We thought there might be a change, and instead we were able to write a test that proved there didn't need to be a change.
Right. Okay. Deirdre, you had a hand up?
The changes to Poseidon, those are just inside the circuit.
It's in the implementation in the Orchard crate. So the external API is unaltered, and other than a small change that might occur to the circuit in terms of refactoring how the padding's done, which might split one allocation region into two. Other than that, the circuit doesn't change. What it's changing is the way it was implemented, which I implemented it in a way that misunderstood how duplexes worked. So this is basically just stripping out all the duplex stuff and just implementing it around a sponge construction properly. This doesn't affect ECC specifically, but it affects anyone who would then use that gadget to implement a different version of Poseidon that might invoke multiple permutations within the circuit. In our case, we only have a single permutation. So all of this is just window dressing on boiling down to a single allocation, a single invocation in the circuit.
Okay, all right.
So this is more, I don't want other people using it until this is done.
Okay, cool.
The use of Poseidon in the circuit was intentionally kept to the simplest case. As mentioned. So.
Yeah, but it becomes necessary in particular to do this, because then when we get to recursive stuff, the Poseidon gets significantly more heavily used.
Yeah. I just double checked. We have a stub. We don't need Poseidon yet because we're not deriving transactions. We're not deriving nullifiers. But when we do soon, we either use yours or we do it ourselves. And so I just want to make sure if it's a moving target of what we need to implement just to derive nullifiers, that we know what the target is. So
the code will end up in the Halo 2 gadgets. Great.
Got it. Okay, cool.
Okay.
Thank you.
All right, very good. And then some additional refactors, cleanups. N-X cleanup is done. Ternary gadget in progress. Next kind of broad category of things, wallet internals, RPC updates, and Orchard transaction support. This was bigger, way bigger actually than we thought it would be in terms of support internally for unified addresses, representation of those in the wallet, et cetera. And then the last item is one more, and I just realized I put 2 I's in internal. One more internal circuit
We need
review.
more eyes on it.
Yes, more eye. Oh, we do need more eyes on it. Exactly. So, So I know most everyone on this call is aware. We had 2 external audits by NCC and QEDIT, as we mentioned earlier, both at the specification implementation levels. One of our kind of gating factors is once we're kind of done with everything, we go back through the circuit with a fine-tooth comb, and we've been making progress on this already. So it's not like we have to start from scratch, but involve our security team as well as the core engineers to do, one more full internal circuit review, internal audit, if you will, of the circuit code again, just for that final thumbs up that everyone is pleased with what they see and comfortable with that, with moving forward as is with the circuit.
So one reason why this is absolutely necessary is that there have been changes to the circuit after the end of QEDIT's review. So all of those changes have had, they've been under a 3 review policy. So that's 3 reviews in addition to the independent of the person who implemented it.
Right.
And this is same policies we use for all of our other consensus changes in Zcash D. So,
but it's not the same as having an external auditor look at it, and that's why we want more eyes on it.
So anyway, so that's kind of the list of remaining work that we have. As you can see, it's a pretty big list. We had hoped to be done with, in particular, the wallet. Let's call it wallet support libraries generically. Within our goal is a month of testnet activation. We're about 2 months of testnet activation now. That's kind of key. Like what you can test on testnet at the moment is kind of sapling compatibility. Does your stuff still work within U5 active, which is good. We've got partners that are doing that right now, giving us some feedback. The real ecosystem work can start in earnest when this is available in a release on testnet. So people can begin to play with, any modified or new RPC they might need to use or want to use to ensure it still works correctly for them. We want, when we launch, support for, as much ecosystem support for unified addresses, shielded by default on the wallet side, et cetera. And of course, we want to make sure that partners like miners are not impacted in any negative way by this. So we can start ecosystem outreach in earnest at that point when we have a release that has kind of the wallet code in it. So obviously a lot of work to do collectively across this series of items. We'll know more within the next week or so on, we're getting very close on a number of these. A lot of these are in review to be merged, but we'll have a better feel for what that timeline kind of looks like at that point when we can wrap some of this up and start doing some ecosystem testing with the release. So
the single wallet bullet point there belies that one's most of what's in the DAG, unfortunately.
Yeah, it's a lot. And fortunately or unfortunately, it's kind of key for, that's the ecosystem partner touch point in a lot of cases. It's the wallet and RPCs. So I know we're kind of coming close up on time a little bit, but any questions or comments or anything? on this list?
Any ETA on the circuit, updated circuit going to testnet and availability, well, implies availability of updated versions of the Orchard crate, so that we can plan to match it.
I suspect at this point that we might almost have the circuit pieces done before the wallet pieces are done, which is not the order I thought things would happen in.
Right.
But-
I'm almost sure it'll be that order.
Yeah, I
Yeah.
think so.
Yeah, the Orchard beta 1 will be, as soon as the incremental Merkle tree piece is done, we can cut that, and then we will have a release of a beta release in Rust Center, so it won't be compatible with 0.10, but it will be within it. So it will just be relying on pinned beta versions rather than pinned revisions, but that should hopefully be easier integration wise. Because incremental Merkle tree is the last dependency that is currently hash pinned. So once we get that in, then you will be able to have a full stack without the circuit change, but that has all those pieces. And then the Orchard circuit change, we've been merging like main Orchard back into that branch as we go. So there shouldn't be any API issues at all with swapping from that I can think of, swapping from Orchard before the circuit change to Orchard after the circuit change.
Okay,
It
good.
should just be change the version number.
Okay.
I have a hard stop. I have to go right now.
Oh yeah,
okay.
yeah,
See
we're
you,
up
everyone.
on time.
See
All
you
right, all right, yeah, we're up on time. So yeah, thanks everyone. We'll keep catching up in Discord async. And everyone have a good rest of the day.
Okay.
Thank
See you.
you.
Bye bye.
Bye.